Hi, I'm Kyle Snowberger, the inventor of high altitude air launch. So this project came about through deductive reasoning. I've always been inspired by space, as you can see. Something that's been intriguing me since I was a kid. Since in 4th grade, I launched a model rocket. And ever since then, I went to Penn State, graduated with a bachelor's in aerospace engineering in 2016, and I still work as an engineer today. What I wanted to see through this project was a way to deliver a large space station into low Earth orbit, preferably an artificial gravity ring. And I thought, how can we deliver one in orbit? Because clearly the reason we have not done so yet is because there's been no lifting body powerful enough to deliver such a massive cargo. Even the mighty Saturn V can only lift a couple 100,000 pounds to low Earth orbit, like Skylab. So I thought, how could we produce a launch vehicle that could do this to make us a true spacefaring race? And I thought, through experience at Penn State, with the Penn State Zephyrus program, we built a human-powered aircraft with a tubular spar, similar to this airfoil here. So I thought, there's a lot of space in an aircraft's airfoil. That cross-section has a lot of promise. So I decided, why don't we make a rocket booster run longitudinally along an airfoil shape and put a payload inside it at the quarter chord or the max thickness point. So essentially what we are doing is we're taking this piece from a Saturn V and placing it longitudinally through an airfoil. And now that airfoil will be extended out and faired at each end with winglets. And it will be launched from the ground underneath a carrier aircraft. And that carrier aircraft can take the form of a Boeing 747, Paul Allen's new Strato launch, or perhaps something that comes out of Virgin Galactic or Scale Composites. The sky is the limit. The idea with this is to increase capacity beyond any launch vehicle we have to date. And Marvel Technologies that I have currently patented, I have patent pending protection on the launch vehicle, which utilizes the forward section to have an oxygen tank, and the rear section to hold liquid hydrogen cryogenic tanks. This launch vehicle also allows flexibility. You can launch from Cape Canaveral's extra long runway, or you can launch from any commercially available 15,000 foot runway, and then take off, fly south, approach the Earth's equator, and then at 50,000 feet or even 60,000 feet under certain payloads, you could jettison the booster. Now I said that right, 50,000 or 60,000 feet above sea level. Currently airliners fly at 30,000 feet. Paul Allen's Strato launch is anticipated to deliver a Pegasus rocket around 30,000 feet. Getting that little extra boost above the atmosphere before your second stage ignites by the rocket equation allows you to logarithmically increase efficiency tenfold. So less fuel is on board to carry a payload to orbit, and that space and that weight can then be taken up for your payload. Moreover, with using a payload booster that creates its own lift, you can also carry less fuel on the aircraft and you can fly higher, faster. With an aircraft going towards the south, you'll have a rocket going east, near the equator. You roll to the right about 10 degrees, jettison the vehicle, and it carries on into orbit. Phase 2 of this program, we might even see part of the booster return to Earth, maybe even as a maple leaf helicopter. Who knows? But currently, the carrier will be reusable and returned to base, and the booster will not be salvaged. This application can also be used for commercial spaceflight. We can launch CubeSats, we can launch microsats in arrays of hundreds, or with a 5-meter diameter standard cargo bay, but with a length of 100 feet, we can launch 2 Hubble telescopes simultaneously, a feat not even the space shuttle could accomplish. Moving forward, this project will take billions of dollars of investment for it to succeed, and I have been blessed with so many opportunities to make this forward as far as I have. I've received pro bono services from Ballard Spar LLP in Philadelphia for my patent application. I have a manufacturer in Wichita, Kansas, a good friend of mine, who will be building a subskill for me, which then I will get to launch at a Cloudbusters high-power rocketry event in Kansas. And I might be able to be a citizen of the United States with approval to launch a rocket from an airborne platform. Afterwards, I'm going to be 3D printing a model for display, so I don't have to use hand gestures anymore. And also, I have made inroads with a company called Cosmos Schema, which their whole business model is making logos for space companies. So I'm at their doorstep. And lastly, I'll make a website and organize my organization more or less as a 501c3 due to the long time before return on investment can be achieved. I'm Snowberger. These are the beginnings of Intercept Nexus.